My name is Megan Kennelly and I'm a plant pathologist at Kansas State University. In this brief presentation, I'll be discussing some trials to investigate different products and application timings for management of large patch and zoysia grass. In a prior video, part 1, which is about 5 minutes long, I showed some examples of the symptoms of large patch. So if you want more information on that topic, you can go to this video. My colleagues Jack Fry and Ken Obasa also contributed to the research I'll be showing here. A lot of our work is done using inoculated plots, meaning that we infect the zoysia grass on purpose with a large patch pathogen. So first, as you see here, we grow the fungus, Rhizoctonia solani, in the lab in Petri plates. Then we sterilize oat kernels and we grow the fungus on those oats. In the fall, usually in September, we take those colonized oats out to the field and we bury them down in the thatch layer. Then we irrigate a lot to promote disease development. In the following spring, we usually have patch development. They start small, like you see here, and then they grow over time. In 1 year, they can expand quite a bit, and over several years, the patches do start to grow large and can coalesce together. We measure both patch size and diameter, and we take images of the disease. The patches don't always have distinct borders, which can make it difficult to measure. And as I said, they can grow large and sometimes they outgrow the plants. And then finally, the intensity of the patch is also of interest. You can see on the left that there's actually more green tissue in there than on the right. So we also take images of the diseases and then we use a computer program to determine the amount of blighting in those. So in recent years, we have run quite a few trials for large patch, and I'm going to talk just about a few of them where we examined fall applications and then also spring, where we looked at both multiple or double and single applications. Okay, so I'm going to walk you through the first study, and it's a little bit complicated, so we'll go through it slowly. In this one, we looked at just one fungicide, ProStar, for some different timings in the fall. The y-axis shows some different timings here, like September 9th, 16th, etc. And then these temperatures indicate the thatch temperature average during the previous 7 days. Here on the x-axis, we see the patch diameter in centimeters as measured the following spring. So let's start with the untreated control at the top. Here, the patches were about 75 centimeters across that following spring. This very first application of ProStar, that should actually be Fahrenheit, not Celsius, that first application was actually not effective. But all of these 3 applications on the September 16th, the 23rd, or the 30th all reduced disease significantly compared to that untreated control. These little letters indicate the significance. So these two, both followed with an A, are not different from each other. These, with B, are different from these here with the A. So here, let's compare a single application on September 16th with a treatment where we did 2 applications, where we applied on the 16th and then again on September 30th. So they're both followed with this B, meaning that adding the second application on the 30th did not increase disease control. Here's another example. Here's a double application where we applied on the 9th and the 23rd, and you can see that it did not reduce disease any further compared to just on the 23rd. It did, of course, reduce disease compared to that treatment on the 9th alone, where we basically just didn't get control. And here's another example where we applied on September 23rd. And then in this treatment, we applied on the 23rd and again on October 7th. And this double did not increase disease control compared to the single. Okay, so this is another study where we applied the fungicides in fall of 2009, and we took data on that disease development in spring 2010. Here, instead of patch diameter, we did use that digital analysis program method that I discussed earlier. Here, we only looked at single applications, no doubles, but we looked at several different products, Trinity, Heritage, and ProStar, at the rates shown here. And again, that temperature is the average temperature in the thatch in the prior 7 days before application. Alright, so again, here's our untreated plot, or untreated plots at the top. And I should say that we did this in a replicated design, so there were actually 4 replicated plots per treatment. This single application on September 3rd with the ProStar, this yellow, did not reduce disease compared to the untreated. But all of the other treatments and timings, the different products on the different days, reduced disease significantly compared to the untreated. There was a little bit of variation through here, but overall fairly similar, and all quite good compared to the untreated. This graph only shows one rating date on May 28th, but the disease severity on other dates that spring was similar. So this photo is actually from a different study than the ones I just showed you, but you can see some of the drastic differences we see in control. Here, this is actually outside the study area with pretty intense disease pressure. Here's a very clean plot, another very clean one, and different levels here. So the fungicides definitely do make a difference. And in quite a few of my studies here at K-State, one fall application has given quite good control throughout the entire following spring. And here's just another picture. You can actually kind of see that the whole patch would be here, and fungicides give some good control right in those plots through here. Okay, so now we'll switch and talk about some spring applications. In this study, we looked at a couple of different products, Heritage, Trinity, and ProStar, at the rates shown here, and some different timings. And we did put our first applications out when the patches first became visible, and the grass had already greened up quite a bit when that occurred. So let's look at this graph where we applied in spring 2009, and we'll go from the bottom up. Well, first let's start, we've got the untreated at the top. We applied on May 1st or May 8th. We also had treatments where we applied on the 1st and the 15th, or the 8th and the 22nd, and those temperatures, again, are the thatch temperatures for the preceding 7 days. And as you see here, most of these treatments don't have that little a, which means they were statistically significantly different from the untreated. So they did reduce disease significantly compared to that untreated control. But you can also see that the magnitude of that decrease is less than in those fall applications that I just showed. I should explain the x-axis. Actually, here we show a measure of disease called the area under the disease progress curve. And this is a way of summing up the cumulative disease severity over the whole season. So this is based on several weeks of patch sizes, kind of all summed up together. As we saw in the fall, in the spring, generally 2 applications did not perform better than 1. This is from another experiment where we applied fungicides in spring 2010, again at the first sign of disease, and the turf had greened up a fair amount when that had happened. In this case, we only did single applications on either April 16th, 23rd, or 30th, or May 7th. We used the area under the disease progress curve again, like I just explained, where you sum up several weeks of data, but this is based on digital image analysis instead of patch size. So all of these treatments that don't have the little a, and there's quite a few of them, they all reduced disease compared to the untreated. But again, like in that prior spring study I just showed you, the magnitude of that reduction is quite a lot less than with the fall applications. So as I mentioned before, in a number of studies here in Kansas, the ones I showed and some others, one fall application has been pretty effective. This may not be applicable to other regions of the country. Here in Kansas, we do move pretty quickly from our cool, wet spring weather into warmer, drier areas where the disease slows down, but the zoysia grass really starts growing nicely. In states farther east, there's a longer, drawn-out rainy period, and my understanding is that the spring applications in those conditions are more necessary and are used more commonly. So right here we move through that large patch weather conditions quicker than some other regions of the country. In our timing studies, we did find that there is some flexibility when the fall applications can be done. There were a number of weeks across September where one application was pretty effective throughout that entire following spring. I didn't show any data related to this, but one option that some turf managers use is to kind of map out the hot spots and focus on those. Large patch does often show up in the same places year after year, and those areas could be targeted. Of course, it can show up in new areas, so it's not like it's only in those same areas year after year, but mapping it out can be one way of focusing those fungicide applications where they are most needed. When it comes to spring applications, the efficacy is lower. In most cases, it can reduce disease compared to not treating it. One thing to just make note of is that some of the DMI fungicides can have some effects on green-up. We didn't see this or look at this specifically in our studies, but I have seen some other reports in other states where that was seen. So that's just something to be aware of, and make sure you read the labels carefully. One potential role for the spring applications would be to hit some of those hot spots that might have been missed the prior fall. And as I said when I showed the studies, our spring applications were done when we actually already saw some signs of disease and the grass had greened up a fair bit. We less about the effect of very early applications. And I know there is some research going on to help get some data on that type of situation. So I've only shown a snapshot of a few studies here at K-State. You probably have your own experiences using fungicides at your own site or talking to people who have managed it, and there is plenty of other information available. For more information on selecting fungicides for large patch and other diseases too, you might try this reference from University of Kentucky. It's a PDF about 20 pages long with a lot of really great detailed information about many turf diseases, including a nice section on large patch. It really is excellent, and I recommend it often. And you can also contact me with questions about large patch or other turf and ornamental diseases, and my email address is shown here. All right, well, thank you for listening.